Hi there. Let's go over chapter 9.3, solving linear equations problems. Example 1. A parking lot contains motorcycles and cars. There are 35 vehicles and 114 wheels. How many motorcycles and cars are there? The table is given to you, so let's fill in what we already know. So we know the number of total number of vehicles will be 35. And number of wheels will be 114. We're looking for how many motorcycles and cars there are, so I'll note it as M for number of motorcycles and C for number of cars. When we're calculating number of wheels, we know that there are 2 wheels per motorcycle, so I can multiply by 2. And 4 wheels per car, so 4 times C. Let's make 2 equations now based on this table. We know the total number of vehicles will be 35, so number of motorcycle plus number of cars equals to 35. For number of wheels, we know there are 2 wheels per motorcycle, so 2m plus 4c equals 114. All right, now that we have 2 equations, let's try solving it by elimination. I would like to eliminate m first. So we're going to set up the equation. M plus c equals 35. 2m plus 4c equals 114. So when you're doing elimination, using elimination method, you need to make sure your variables are lined up and the constant as well. And then we need to find the LCM of 1 and 2. LCM would be 2. So I'm going to multiply the first equation by 2. Let's rewrite this equation. We get 2m plus 2c equals 70. We're going to carry over the second equation as it is. So we have this. Now that we confirmed that coefficient in front of x equals to each other, so we're just going to subtract the second equation from the first one to eliminate m. So m's get cancelled out, and then we have negative 2c equal to negative 44. Let's isolate c by dividing both sides by negative 2. So we have c equals to 22. Right? And then next step would be subbing back into equation, the original equation. So I'll sub into equation 1. So our equation 1's this. I'm going to sub that c equal to 22 into our equation here. All right, let's isolate m by taking away 22 on both sides. We have m equals to 13. All right, so final step would be stating your solution in words with correct units. There are 13 motorcycles and 22 cars in the parking lot. So that's it for example 1. Example 2. It takes 3 hours for the canoe to travel 45 kilometers downstream. The return trip going upstream takes 5 hours. What is the speed of boat and speed of current? Again, the table is given. Let's fill in what we already know. we know that the distance will be 45 kilometers going and returning. The distance doesn't change. All right, so for time, we know it takes 3 hours going downstream and 5 hours going upstream. What we need to know here is that we want to know what the speed is going down. We know that there are two things we need to consider: speed of boat and speed of current. So let's quickly go over why there's two different types of speed in this case. So when traveling downstream, the canoe is traveling along with the current. So let's say the speed of boat is noted as B and the speed of current is C. Then the speed going downstream would be the at sum of the two speed. So the boat speed is added onto the speed of current. So you're moving along with the current. Okay, you're faster that way. Whereas when you're returning, going upstream, you're going against the current. So your speed of the boat will be decreased by the speed of the current. Okay, so whenever you get questions like this where there is a speed of boat and speed of current or two different type of speed combined together, this is how you set it up. Let's take a look at setting of equations. What we first need to know is our physics formula: speed equals distance over time. It'll come back quite often. All right, so now that we know the speed has to equal to distance over time, we're going to set it up. We know for the first equation, let's say we're going downstream, speed is b plus c. And the distance is 45, and the time it takes is 3 hours. This is just 15. So when we rewrite it, it's just b plus c equals 15. Equation 2, same idea. Speed is b minus c equals to distance 45 over 5, and this equals to 9. So b minus c equals 9. I want to first eliminate b. By the way, for this section, it's okay to use either method, either substitution or elimination. But if you take a look at how my equation turned out, this is, I think, easier to do elimination method. So let's eliminate b. All right, so the coefficient, or the b's and the c's constants line up well, and so let's just check the coefficient. They're both 1s, so I don't have to do anything to the equation. I just need to subtract the second equation from the first equation. So we get c minus negative c, double negative, so it becomes positive, so 2c equals 15 minus 9 is 6. Isolate c by dividing by 2. We get c equals 3. We're going to sub this into, and then sub into equation 1. It's okay to sub it into equation 2, it really doesn't matter. So b plus c equals 15. I'm going to sub 3 into my c here. b plus 3 equals 15. We isolate b by subtracting 3 on both sides. We get b equals 12. All right, so we can say that the speed of the boat is 12 kilometers per hour. Notice my unit depends on the unit for distance and unit for time. So distance over time, so kilometer per hour. And then the speed of the current is 3 kilometers per hour. So that's it for example 2. Moving on to example 3. The tickets to a museum cost $7 for a child and $12 for an adult. On a particular day, 233 people attended the museum, and there was a total revenue of $2,216. How many tickets of each type were sold? All right, so that's what we're looking for. How many tickets of each type were sold? So number of tickets for children is unknown. I'm going to denote it as C for child and A for adult. But we know that there were a total of 233 people on that particular day. So total is 233. Revenue can be calculated by multiplying 7, because we know it's $7 per child and $12 per adult. And the total revenue was $2216. Let's set up the equations. So the first equation would be number of children, the tickets, children's tickets plus number of adults ticket would be 233. And the second equation would be how much you're earning from the tickets. So 7 times C plus 12A equals total of $2,216. All right, so let's solve for C and A. I like to use elimination method, and again, it is totally fine to use substitution method. It's all up to you. I will first check. Actually, let's eliminate C first. Eliminate C. So I want to check the coefficient in front of C. It looks like there's 1 and 7, so it won't do. We will first have to multiply the first equation by 7, because LCM of 1 and 7 is 7. Let's rewrite it. First equation becomes 7C plus 7A equals 1631. Second equation carries over. We'll leave it here. And now we confirm that the coefficient in front of C are equal, so I can just subtract the second equation from the first one. All right, so 7C's cancel out. We will have 7A minus 12A, which is negative 5A. And on the right-hand side, we have negative 585. All right, in order for us to isolate A, we need to divide both sides by negative 5. So we get A equals 217. We're going to sub this value into first equation, the original one, sub into equation 1. C plus A equals 233. I'm going to sub this into here. So C plus 117 equals 233. we isolate C. So we get, what do we get? C equals 116. All right, so last step. There were 117 adults and 116 children. That's it for example 3. Example 4. Corinne's mom is 25 years older than Corinne. In 2 years, Corinne's mom will be twice Corinne's age. How old are Corinne and Corinne's mom? All right, this time we don't have a table value or a table, so we'll just have to set it up from scratch. So first we need to look for some variables. We'll state it as C for Corinne and M for Corinne's mom. More like Corinne's mom's age and Corinne's age. So let's label it here. So M is mom's age and C is Corinne's age. All right, so first equation could be formed by the first sentence here. So Corinne's mom is 25 years older than Corinne, so Corinne's mom's age is equal to Corinne plus 25. Second equation would be in 2 years, Corinne's mom will be twice Corinne's age. So basically, in 2 years, so that means you're adding 2 to their current age. And we know that Corinne's age is double of mom's age in 2 years. But what we need to consider is that mom is not the only one who's gaining 2 years. Corinne is also gaining 2 years. Okay, so you do have to add 2 to Corinne's age first, and then you need to double it. Okay, so the order matters. You can't do 2C plus 2. It doesn't work that way. Okay, so you always have to add, not always, but like in this case, you do have to add into the C first. All right, so we're just going to expand the second equation a little bit so we can actually have nice equation. So we have left side alone here, and then we can say 2C plus 4, and I'm going to isolate M just because we have 2 constants on both sides. So let's take away 2 on both sides. We have M equals to 2C plus 2. All right, so we have 2 equations. Maybe this time, instead of elimination, we can try substitution. So we have M equals M. Because we have m's isolated here in both equations, we can just set it up now. So first m would be the first equation expression here, C plus 25. And the second m on the right-hand side would be the second equation expression for m. Let's collect the like terms by taking away c on both sides. So we have 25 on the left-hand side, we have c plus 2 on the right-hand side. I'm going to subtract 2 so I can collect the constants together. So we have c equals to 23. We're going to sub this back into one of the equations. Sub into equation 1. So we have m equals 23 plus 25. So M equals 48. Finally, we can state that Corinne is 23 years old and her mom is 48 years old. That's it for example 4. And for the challenge problem on the bottom of the page, I want you guys to attach the solution to your chapter 9 assignment for bonus mark. We'll go over it after. All right, good luck everyone. I'll see you guys in the next video.